Assalamualaikum and a very good day to all. Okay, sorry for taking you too long for recording this video. Basically I'm taking a leave for several days, so I cannot manage to do our online classes, so sorry for that. Because we cannot do our class. It is like 4 hours for Sunday in Monday, isn't it? That's why I need to come up with this video so that we can catch up. We need to finish our module 4. Basically we already touched a little bit, and in this slide also, if you see this slide also, we already cover. Basically I just want to do some recap before we can go further. So let me proceed. I hope that all of you are in a good health. Okay, mapping non-standard SOP expression. Last time we did cover a little bit, especially in this SOP, non-SOP, POS, non-POS, and etc. So you already know how basically you can convert from non-SOP to SOP. Where's my marker? Okay, from non-SOP standard to standard SOP. So there is several rules for you to convert from non to standard, non-standard to standard. And for SOP, if you still remember, you need to use these rules. I also forgot already. I think this is rule number 6. And because of this, you need to do like several multiplication times, so you need to have like step by step. And this also I already cover. If basically you need to you were given with non-standard SOP expression, when you need to do the K-map, you need to convert first to standard. Whether it is SOP or it is POS, you need to convert it first. But to convert, you need to do several steps, which is it's basically took longer to you to convert. That's why in term of you to convert using several rules, why don't you just use the logic for you to come up with your K-maps? So you were given with this example, and we already touched these things basically in our class, but I just do a recap. So if let's say you were given with this SOP Boolean expression, what you need to do is you need to convert it to to standard. But yeah, there is too many steps to do. That's why you're going to do a logic. If we can see here, this is non-standard, this is non-standard, this is standard. So the standard, you just left it, and you need to settle these two product terms. So this first, you're going to make it like this. A bar. What is A bar? A bar in SOP, it is going to do 0. So because this is a 0, you're going to fix it. And what is missing here, it is a B and C. That's why you need to check what is the possibilities for you to have B and C. The possibility will be 0, 0, 0, 1, 1, 0, and 1, 1. And you combine it all together, you're going to get 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. This is the things that under SOP your output will be 1. So you look and map it into your K-maps. 001, 001, 000 is going to be 1, 001 you're going to get 1, and etc. So this will already cover. So I hope that you do a recap, you try several Boolean expression, you do your own Boolean expression and come up using your K-map. So we did take a look also in terms of how you can do the step by step on simplification. So here I do a recap for this for you to remember back, refresh back your mind to check how you're going to map it if let's say it is non-SOP or non-POS. Here we're going to come out with the simplification version. So there is a step by step. Of course you need to remember the step by step, but if you already know, it is directly easy for you. This one I already covered, but let's check basically how we're going to draw. I asked you to check upper, left, right and bottom. If there is any bersebelahan, or what we call it as adjacent to each other. So here you can see there is no adjacent, that's why you can group it like this. And check back, okay, for this one over here, you have adjacent at the lower part, you can have these 2 because you cannot have 4. For this side, you have the adjacent that beside here, that's why you can group like this. What is the Boolean expression you can come out by using this K-map? It is, as you still remember, I asked you to check which part is fixed for the input. This is fixed. The C is that did not change. For this one, C is 1. For this output, the C is 1. So C is 1, C will be C. You check this side. For 1, this you're going to have A is 0, B is 1. This one, because you want to come out with this circle, right, this group, so you need to check this part. A is 1, B is 1. So you can see A is changing, so you need to remove it, but B still maintain, B equal to 1, so you put B here. So this is the Boolean expression for this part. For this side, it is easier because it is single group, so you need to see what is the input. A is 0, B is 0, C is 0. So that's why you will having A bar, B bar, C bar. And last group at this side, you're going to have, you check the upper side for this grouping. You can see this group having C is 0, and then after that this one C is 1. So that's why C will be removed. And you check over here, A is 1, B is 1, and didn't change anything. That's why you will get AB. This is how you come out your Boolean expression from the K-map. And whatever come out here, if you correctly write down the Boolean expression and you correctly group it, then that is the simplification version for your expression, Boolean expression. So let's take a look like this one. I can see there is a possibility to have this circle, square, this rectangle for, and yes, this one. So you can come out with your Boolean expression over here. My C is maintained, which is C bar. D is moving, I don't want it to change. The 1 is maintained, here is A bar. So this is how you're going to come out your Boolean expressions. Determining minimum SOP from a care map. This is the thing, this similar thing what we have done. You can see here what are, okay, might be, okay, for these things we also already cover, I guess, in our class. You can see here 1 1 1 1 1 1 1. We have one circle here, another circle, grouping. For this side, you need to check it is covered here, it is covered here. So you need to check the input. OOC is changing the value, so you're going to ignore C. And how about this AB input? Oh, the maintain is B bar. So the A here is 0, here is 1, so you're going to remove B is maintained, it will be a B bar because it is 0. So that's why you're going to come out that this is your Boolean expression. And same goes to other thing. So if you have any question how you're going to group, how you're going to come out with your Boolean expression, the simplification version, so please ask me, WhatsApp me, and ask me in the class also can. So you can see in terms of expression, if you group, you don't know, is it this is the correct answer or not? So there is a possibilities. If you group two cell together, you're going to have two variables. If you group one cell here, you're going to have three variables. If you group 4 cells like this one, you're going to have one variables. If you group 8, expression value will be only one expression value. Okay, what is expression value? If you get it, then you need to know how basically it's look like. Okay, maybe we can see the example 8 over here. You can see this one is 8, so you have one variables. Expression value, this one is 16, this one is Excel, one variable, sorry. So for 16, I look at this. Okay, this one you need to have for 3 variables input A, B, C. So this is the things that you're going to get. 1 cell you get 3 variable, 2 cell you get 2 variable, 4 cell you get 1 variable. But it is different if you have 4 inputs. You're going to have 1 cell for 4 variables, 2 cell for 3 variables, 4 cell for 2 variables, and etc. So this one to guide you whether you get it correct or not. Okay, to guide you. Okay. Okay, group the one in each of the care map below. Let me try to draw mine. This one, the things, similar things that we have just now, I guess. The example given. Okay. This side, I have several possibilities. I think I can group like this. Yeah, that thing also can. This thing also can. Yeah, there is a several possibilities for this one to group. Then, sorry, I can see there is 4 here. Let me see. Okay, this one is 4 there. And this side and this side. Okay. this is my grouping. Okay, please try to do and check whether your answer is correct or not, like my care maps. Okay, you can see here, yeah, mine is correct. Okay, then it asks you to write the minimum SOP expression. So here it will be A, B, C, bar, 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 because O input is 0 for this cell. So for this cell, this is basically the similar, right? You're going to have for this cell, you're going to see this one is maintained, it is A, B. Then another one is B, C. Try to do and try to look whether it's okay for you to note. Okay, this one example. How you going to draw your care map, but instead of changing it to a standard SOP using this rule, you can also use the logic. But if you think that only one step, because you have only missing one variable, so you can do it also using the standardization step. So you just come up with the value 1 0 0 0 0 0 0 0 0 1 0 0. If you still remember 0 0 1 1 1 0 1 1, because this is SOP A equal to 1, A bar equal to 0, F equal to 1. 0 1 1 0 1 1 1 0 1 0 1 0. So all this value, your output will be 1. So you just map it into your care maps. And you can see here the exercise here, it's asked you to use your care maps to minimize the following standard SOP. So you have this, you just map it in using this method. You come out the value 0 0 0 1 0 0. Then you map all these values to be your output as a 1. After you already done, then you can do minimizations. You're going to have the minimization for your Boolean expression there. So from your Boolean expression, you can come up to your care maps. But if you were given with your true tables, last time you were given with a Boolean expression, you need to come out with your true table and then your care map. But now you were given your true table, you need to come out with your care maps. It is simple. You just see the value, what is the input available, and then you check if you pick the 1 here, if you pick the output as 1 here, it is SOP. If you pick the 0 part, it is POS. So you just map your care map. So last time I also already informed you that we're going to look into don't care. What is don't care? Don't care is the things that invalid for your BCD. So which part is don't care? Don't care is starting at 1010, 1011 and until 1111, if you still remember. So everything's your inputs until 1010. Okay, if you have for input, let me see. You can see here 1 0 1 0 until 1 1 1 1. Your output will be don't care. Why you put don't care? Because there is a possibility that it is not allowed or invalid combination for BCD. That's why we put the output as don't care, and don't care is represented as X for your output. Last time you only have your output will be either 0 or 1, but now we need to see there is also possibilities of don't care, which is X. And for X can be 0, it can be also 1. It depends on your truth table. So you need to find the possibilities to have 16 cell group, 8, 4. So by using this X, it help you to have bigger cells groups. So that's why it's good for you to have don't care there. But sometimes you can also ignore it, depend on your situation. So let's check what is the possibilities happen there. You can see you were given let me draw my cam maps. One. See here, don't forget it's already 1 week, you more than 1 week you didn't touch this subject. So I hope you still remember this one things. So I map here 1 there, 0 1 1 1 0 0 0 1 0 1 1 1 1 0 0 0 1 0 0 0 1 0 0 1 1 0 0 1. Okay, and then for axis it would be 1 0 1 0 1 0 1 1 1 1. This one is all axis, sorry. 1 0 1 0 X 1 0 1 1. Okay, now here I have this 1 2 3 4 5 6 1 2 3 4 5 6 6 axes. I have 3 ones, and the rest will be 0 0 0 0. So I want to change the color. Okay, now I'm going to groups. So I have this X over here. I have the possibilities to draw this big axis over here just to fulfill add cell. Now I have another one. It will be like this. So what is my simplification version for my Boolean expression? It will be everything change over here, or the thing is only A, and here will be CD. So this is my Boolean expressions. Let's see the answer. Okay, so this is the things you can see. You get A over here, and another one you group like this, you will get A, B, CD. Oh, I put only CD, sorry, I forgot the B over here is fixed also. So B, C, D. You can see over here, this is the things when you have access and you group it. So this will be having F equal to A plus B, C, D. But if you ignore the access, which is you assume it to be 0, you're going to have F equal to A, B, C, this one, And another one is you circle single cell, you're going to get A, B, C, D. So you can try to simplify it. You're going to get the most simplification version because that is involving the XXX there, and this is the correct answer. Without, don't care, and with don't care. If you ignore the don't care, without don't care, which is you're going to get this one. If with don't care, which is you assume x equal to 1, for this part, this and this, you're going to have like this. So this is the invalid input for BDC. Now use K-maps to minimize a standard SOP expression. Okay, you were given like this, and you were given also the term of use don't care. So that's why you have like this don't care, which is D. 6 and 7. What is the meaning by 6 and 7? You're going to convert it to your binary. You're going to have 1 1 0 1 1 1. So at this part, it's going to have access. Let me draw my K-map first because I have these 3 variables. I'm going to draw like this because it's much better to view. A here and BC here, 0 1 0 0 0 1 1 1 1 0. I have here 1 0 1. This part is 0 1 1 0 0 1 0 0 0 1 0 0. So for here 1 0 1 0 1 is 1 1 0 0 is 1. Kenapa I draw dekat atas? 0 0 1. Okay, betul. 0 1 1 is already done here. This side is 1 0 0. Okay, 1 0 1 1 0 1. Okay, 0 0 1. Ada dua ke? Apa ni eraser? Let me see my eraser. Okay. Here is 0 1 1 0 1 1 at this side. Here is 0 0 1 this side. Okay, and lastly 0 0 0. It will be like this. Okay, now my D, which is don't care, at 6 I convert to binary, I will get 1 1 0. 7 I convert to my binary, I'm going to get 1 1 1. So at this side I have don't care, 6 1 1 0. Here will be access 1 1 1 x over here also, and the rest will be 0. So let me draw my grouping, including my axis, which is my don't care. I have like this. 1 I have another one only. So can I have like this? Yes. Because over here is 0. If I didn't miss anything up here. Yes. So I have two groups there. So what is my answer? I will have B bar, and another one will be C plus. This is my F. So this is how you're going to draw, because you can see you assume this X will be 1 and this X you're going to put it as a 0. So that's why you ignore it. I can have like this also, but instead of having that, I already have all one already grouping, so I just ignore. So let's take a look the answer. If I didn't miss anything, yeah, there will be like this. Yes, so it's similar to my answer, but in terms of different view, you can see over there how it's mapping. My care maps is slightly different, but it is basically similar. I think you can have the horizontal and vertical way to draw your care map, right? So try both. And you have another one over here. Use care maps map to minimize an X expression. How are you going to do? You're going to convert your decimal to binary. And you have this for your Boolean expression, and this one is your don't care. So try to take a look and do the exercise. So over here you can see, let me see, okay, I can convert it F equal to 0, 0, 0. What else? 1, 0, 1. Of course, I have 4, right? 1, 0, 0, 0. 1, 0, 0, 1. And lastly, 11, 8, 0, 1, 1. I hope it's correct. Direct convert. You can check it whether my answer is correct or not. I convert it directly from decimal to binary, and my don't care or my D over here 0, 0, 0, 1, 0, 0, 1, 0. Another one is 10, 1, 0, 1, 0. So let me draw my care maps. So this exercise you can try to do also by yourself. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Ayo. So I have here is 1, 0, 1, 0, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1. And my don't care is 0, 0, 0, 1, 0, 0, 1, 0, and 1, 0. Okay. I have this view, so the rest will be my 0. So let me draw my grouping. I will have this side one. I will have okay, this side first. I'm going to have like this, and this I will try to do it as full. Okay, why I pull it as maximum? Because the maximum is much better. So I'm going to come out with my Boolean expression. So Allah. So that thing you come out with your Boolean expression, the thing is similar, but this one is standard versions. You're going to have the minimized versions using your KMap. So that is the things. Now let's move to the KMap POS minimization. It's basically similar like your SOP, only for POS you're going to put it as a 0 for your output into your KMap. So the things, everything over here, you're going to put 0. So you're going to group 0 instead of 1, because POS we will follow and grouping 0 there. And ignore the 1. In group 0 instead of 1. So it's totally similar. You're going to group the 0 over here. Let me see what I can have. So I can have like this. So the rest 1 1 1 1 you're going to ignore for your POS. It's totally similar things. So you can see over here, this is your POS. You can get your SOP also for your Boolean expression for your SOP. But if you need to minimize POS, you're going to get this answer. And you can see minimize the POS expression. If you can see here, it is non-standard. It is similar to the example of your SOP. This is missing only A. So you change it to be standard POS, and you get the value of your binary. Then you're going to map. So no need for me to go like one by one, because it's totally similar, only the different at 0 side. And how you come out is similar things also when you group. You can see over here, when you group, you have this, let's say this side. You need to check what is the input that stay similar. So the only thing over here is C0, D0. A, B is all changes. So C0, D0, please remember POS. A will be 0, A bar will be 1. That's why if it is 0 and 0 here, you're going to have C plus D for your POS. And the thing here also similar things. If it is 0, you're going to have a non-bar. If it's 1, you're going to have bar like this. So you can also getting the conversions of POS to SOP using KMap. The thing is similar thing, which is you have basically the SOP inside one through a KMap. You can also have a POS in one KMap. So if you were given with POS, you can convert to SOP. When you have SOP, you can also convert to POS by using these KMaps. Convert between POS and SOP using KMaps. So you were given all the value, you just pick. If you want to have SOP, you pick the one over there. If you want to have POS, you just group the 0 there. So this is SOP were given, and you map it into your KMaps, and you come out with your POS. So you group and try to find out the value. So this all the exercise, you can try to do it. Okay, you have several things, which is you need to convert it from non-standard. You can see non-standard, you need to convert to standard version first. Similar also for next example, you have non-standard versions. You need to apply your De Morgan theorem to convert to a standard expression. Then after you have the standard, then you can map your K-maps. So last subtopic, which is your simplify combinations of logic circuit. So that's why after you have the simplification versions of your K-map, you can easily come up with the circuit. That is the simplified versions of your circuit. So there is step by step. You can check what is the step for you to convert and simplify the logic circuit. So given the logic circuit below, you were given this logic circuit and the De Morgan theorem. So let's check what is the input available, get the final output expression. When you have the output expression, you need to do the standardization first. If you already do the standardization, step 3, you need to do a standardization. You need to apply the De Morgan theorem or rules and also law. Then you will get the final answer. That's why when you have the standardized versions, you're going to get the simplified versions of your logic. So the step is, first you need to come up with your value of input. What input that available, and what is the Boolean expression for your logic circuit given in this picture. So in this picture, you can see you have x equal to a, b, c, bar, 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 and bar, c, and blah, blah, blah over here. This is your Boolean expression. So from there, what you need to do, you need to do standardization. You're going to apply your law. You're going to apply your rules. You're going to apply your De Morgan theorem. So after you apply all of that using step 3, then you're going to have your final versions of your logic circuit. So here also there is another example. You can try to do this example also. So follow the step by step, step 1, step 2, step 3. And there is also tutorial. So only that for your module 4. You have another last one, which is basically is a summarization for all your module 4 under your K-map, under your Boolean expression. So that is the things over here. Okay, you can try to screenshot how all the expression, the SOP thing, the POS thing, the truth tables, how the standardization, what rules. Rules number 6 for SOP, for POS, what is standard versions, how you're going to do standardization using rule number 8, rule number 12, and using the K-map, how it's going to be look like, and also your don't care. So I hope that we already cover all our module 4. Next we're going to look into our module 5. It is quite exciting also. Still you will need to have your knowledge on your Boolean expression, but we look into our gates and also circuit, and we need to do also our lab 2. So I think only that for today. Thank you and stay safe. Bye bye.